Mr. Donatelli. This is Andres Insignares, and this is my first video question. The question says, find the tension on the ropes 1 and 2. We can see that the picture is a 13-kilogram box that is held by 3 ropes. Rope number 1, rope number 2, and rope number 3. To solve this question, we need to do a series of steps. The first step is to do the free body diagram. The free body diagram of the middle point will be this. 3 forces of tension are acting on the middle point. Now we need to do the coordinate system, which is like this. The next step to solve this problem is we need to divide these two triangles into the x and y components of force of tension number 2 and force of tension number 1. To divide force of tension 1 and force of tension 2 into y and x components, we need to draw the triangles. This is triangle number 2. And triangle number 1. And FT2. We know that this is a right angle. These are right angle triangles. So we can find the next angle, and we can also find the x and y components using SOHCAHTOA. So we found the two angles that were missing from the triangles. Just by using algebra, we know that 25 plus 90 plus angle A must equal 180, so we know that A is equal to 65, and we did the same thing here, and we saw that this angle was 80. So we need to divide our triangles into x and y components. So this is FT1x and this is FT1y. FT2x and this is our FT2 FT2y. So now we just have to use SOHCAHTOA to find and divide our triangles into x and y components. So we see that FT2x is equal to FT2 and sine of 80, while FT2y is equal to FT2 and cosine of 80. We know that cosine of 80 is equal to 0.98 and sine of 80 is equal to 0.17. So we put FT to simplify our values. And we do the same thing with the other triangle. Other forces and divide them into the x and y so that we can find the net force of x and y. So we see that x we got from tension from force of tension number 2, we got 0.17 F2, which is negative because of our coordinate system, and we can see that this is going this way, which is negative according to our coordinate system. We also got from force of tension number 1, which is 0.9 F2, F1, FT1. In our y direction, we got 0.98 F2 and 0.42 F2 F1, and both of these are positive since our coordinate system shows that they are both going upwards, so they are both positive. But we also got another force of tension, which is force of tension number 3, which is going in a negative way and it's going in the y direction. And we don't know which is force of tension number 3, so we sum up all the forces and do the F net. So the net force of the x direction is equals to 0.9 ft1 minus 0.17 ft2, while the net force of the y direction is equal to F plus 0.42 ft1 minus ft3. So now that we found what are the net forces of each of the directions, we can find our variables. Our next step in this question is to find what is ft3. To find what is ft3, we have to do the free body diagram of the 15 kilogram box, and we see that it has force of tension going up and force of gravity going down. We also do the chart because on the y direction only, since it only has forces on the y direction, which are force of tension and force of gravity. Force of gravity is equals to mass times 9.8. Since the mass is 15 kilograms, we can find out that the force of gravity is equal to 147. So we can do the net force of this, which is equal to force of tension minus 147. Since there is no acceleration on the 15 kilogram box, it's not moving, so we can apply our laws of Newton, which says that if acceleration is equal to 0, then the net force is equal to 0, so we can say that net force here is equal to 0. And we can see that ft3 is equal to 147. So now we can use this variable and replace it over here in the y direction. We can solve for our variables ft1 and ft2. We know that acceleration is 0, so we apply the first law of motion, which says that if acceleration equals 0, then net force equals 0. So we can see here that we put that the net force equals 0, and here too. So now the next step is to do some algebra and some substitution to find out which is ft1 and which is ft2. Now that we know what is ft2 is equal to 5.29 ft1, we can replace it here in this equation and solve for ft1. We found out that ft1 is equal to 26.25, and we have to use substitution again and replace it over here to see what is the tension in FT2. The last step to finish this is to just put the directions of each of the two. So force of tension on rope number 2 is equal to 138.86 newtons, which go in the positive y 80 degrees and then negative x direction. And the force of tension on rope number 1, which is equal to 26.25 newtons, which go in the positive y direction 65 degrees and positive in the x direction. And this is all. I hope you understood.